So I am going to start chapter 2, that is solution. As I informed you earlier that according to current paper style, there are 3 MCQs and 1 question of 4 marks from this chapter. So let's begin. First of all, what is solution? Solution is homogeneous mixture of solvent and solute. Again, homogeneous mixture, this word is important. Homogeneous mixture of solute and solvent. What is solvent? Whichever component that have higher proportion in the solution is called solvent. Solute, whichever component which have less proportion, that are called solute. Now there are few types of solutions. One of them is binary solution. What is binary solution? Basically it has one solvent and one solute, that are called binary solution. Example, water and NaCl. Here water is solvent and NaCl is solute. So it is binary solution. But if we consider lemonade as solution, it is not a binary solution. Now there are few types of solution: solid, gas and liquid solution. That table we already discussed in classroom, so I am not going to discuss it again. Now next point is few important points related to solubility. First point, polar solutes are soluble in polar solvents. Again, polar solutes are soluble in polar solvents and non-polar solutes are soluble in non-polar solvents. Which are polar compounds? H2O, HCl, CHCl3, CH2Cl2, NH3, CH3Cl, NaCl, KCl, Ki, etc. are polar compounds. What is polar compound? Let me explain you. Suppose I am taking HCl. Here there is one covalent bond between hydrogen and chlorine. Now due to higher electron negativity of chlorine, this electron shift towards chlorine. So this bond becomes little bit polar. So chlorine develops partially negative charge on it. On hydrogen there is partially positive charge. So HCl is polar compound. Like that, in water oxygen has higher electron negativity, so it attracts electrons from two covalent bonds and hydrogen develops partially positive charge and oxygen develops partially negative charge on it. So it is polar compound. What is non-polar compound? Suppose I am taking methane molecule here. It has 4 hydrogens around the carbon. All 4 hydrogens have same electron negativity. So the bond electrons will remain as such between carbon and hydrogen. So it is non-polar. And HCl, H2O both are polar. Okay. Now I am speaking out the names of these compounds. Listen to me carefully. Water, hydrochloric acid, chloroform, dimethyl chloride, ammonia, methyl chloride, sodium chloride, potassium iodide. Non-polar compounds: carbon dioxide, C6H6 that is benzene, CH2 that is carbon disulfide, CCl4 that is carbon tetrachloride, CH4 that is methane, C2H6 that is ethane, C2H4 that is ethene, toluene, etc. So this was the first point. Now second point regarding to solubility is, as the number of OH group, that is hydroxyl group or alcohol group, increases, solubility in water of that compound increases. Suppose I am taking here example methanol. The formula of methanol is CH3OH. It has only one hydroxy group in it. Then second one is ethylene glycol, CH2OH, CH2OH. It has two hydroxy group in it. And third one is glycerol or glycerin, CH2, CH, CH2. All three carbons have one OH group on them. So it has basically three hydroxy group. So solubility of order of these three compounds are third greater than, second greater than 1. So most soluble compound in water according to this second point is glycerol, then ethylene glycol, then methanol. So next topic is units of concentration. This topic you have already learned in 11th standard. There are few units of concentration: molarity, normality, molality, percentage weight by volume, percentage weight by weight, percentage volume by volume, ppm, and formality. Now here are the formulas, and let me just correct it. There is some mistake. So if you have this formula, keep it with you, and if you don't have, then write it down here. Pause the video and write it down. It is very important. Later on we will calculate some examples from it. These are first 5. Just pause the video and write it down. These are the 7th and 8th. These are formulas. Now few important points for exams. First one, formality. The unit formality is very useful in medicinal chemistry and pharmaceutical uses. This question was there in board exams, so note it down. Formality that is useful in medicinal chemistry and pharmaceutical uses. Next point, ppm, that is useful to measure pollutants in air and water. COD, BOD in measurement, and useful to derive how much of oxygen is soluble in water, especially in seawater, how much oxygen is there. That measurement is done in ppm unit. Now third point, as we know, with increase in temperature, volume increases of any compound, solid, liquid or gas. With increase in temperature, volume increases. So because of that, unit of concentration which have volume term in their formula, that changes. Like I am taking here example formality. It have volume term, volume of solution in ml. So if I change the temperature of that solution, this volume will change. So ultimately formality will change. But with a change in temperature, mass remains unchanged. Mass remains as such. So if I am measuring the concentration in ppm and I am changing the temperature, the ppm unit will remain as such. So ppm do not change with temperature. Now I am giving you work. There are 8 units of concentration here. Find out which units will change with temperature and which unit will not change with temperature. Okay. Now next topic, that is solubility of solid in liquid. Again, solubility of solid in liquid. Solid is our solute and liquid is our solvent. So liquid is solvent and solid is solute. Now this solubility depends on 3 factors. First one, nature of solid and liquid both, means solvent and solute both. Nature of these both affect on solubility. How? We already discussed. If solvent and solid and liquid both are polar, then it makes a solution. But and both are non-polar, it can also make a solution. But one is polar and one component is non-polar, then it does not make a solution. Like I am taking an example here. If I try, suppose I am taking a beaker that is filled with water. Water is already we discussed polar compound, and I am trying to dissolve a solid naphthalene balls in it. This mixture does not make a solution because naphthalene does not dissolve in water. Naphthalene is non-polar compound and water is polar compound. Nature of this both is different, so it does not make a solution. Now second point is temperature. Before that, let me explain one simple term. What is dissolution process? So I am taking a beaker full of water and I am adding NaCl in it. Now this NaCl and water will make a solution, but not immediately. First I have to add NaCl, then I have to stir it by rod or by some stick. I have to stir it then and then only that can make a solution. This process of stirring is called dissolution process. So what is dissolution process? Process to make a solution, that is called dissolution process. Okay. Now if that dissolution process is endothermic process, again, if that dissolution process is endothermic process, then with increase in temperature, solubility increases. With increase in temperature, solubility increases. And dissolution process is exothermic process, then with increase in temperature, solubility decreases. And third factor is pressure. Basically it's not a factor, because as pressure do not affect on liquid and solid, Solubility of solid in liquid remains as such. Pressure factor do not affect the solubility of solid in liquid. Okay, so these are few points of today, and this is your homework. Answer these questions. Pause the video here and answer these questions. I'll send you a photo of this question in WhatsApp group. You have to answer it and submit me tomorrow. Thank you.